So next up, we've got Donald Sumbry, or just Sumbry, and he's going to be talking about production engineering competencies. Hand it over to you, Sumbry.
All right, what's up, everyone? So yeah, I'm going to be talking about growing and scaling production engineers. So what are we going to talk about? A few sections here, a little bit about myself and the team, you know, how we accomplish some of what we're doing, our hiring strategy and how that works, how we actually evaluate production engineers, and then we'll leave the end of this for questions. So to kind of get things started, yeah. So a little bit about me. My name is Sumbry, technically Donald Sumbry. Everyone calls me Sumbry just by my last name. Been called that all my life, so I don't fight it anymore. I'm the head of Uber Production Engineering here. We recently rebranded our name from SRE. If you hear me use the word SRE at any time during this talk, I will give you $1. All right, and first person to call it out. And I'll go into a little bit about why we've actually rebranded ourselves and why we refer to ourselves as production engineering and production engineers. Been in the industry, obviously, for quite a while. If you want to connect with me afterwards, LinkedIn/Sumbry or just @Sumbry on Twitter, Facebook, etc. So a little bit about our org, because I think this is really important to call out. We kind of view the world in very simple terms. You know, on one level, we have product engineering, and these are people that build products or features and deliver those to teams. So if any of you are familiar with Uber, that's things like Uber Eats, Uber's money systems, Uber Maps, and Uber's marketplace. The marketplace is the core part of Uber. That's what most of you are actually interacting with when you get matched with a driver and you take a trip with Uber. And so what we've actually done is we've created a production engineering group that creates teams that partner with these product engineering teams or these feature teams. And so that's specifically like the mode that we use to operate. We specifically partner with feature teams, and then we help improve the reliability of those teams. And if you look at our org at a very high level, like why are we here? Why do we exist? What are we supposed to do? You know, and we have this notion that in the same way that Uber has driverless cars, we should have driverless infrastructure, quote unquote. And what I mean by that is our infrastructure, you know, we hire engineers to basically build, operate, and automate so that these things just sort of run themselves, you know. Now, it takes years to actually get, you know, to that full level of automation, but the notion is that that's what our North Star is. That's actually what we're trying to do. And so a lot of this talk is going to focus on specifically how do we find people to help us actually build and do those things. And then in addition to that, you know, if you really think about the mission of our group and, you know, what we're kind of set to do on the more immediate time scale, it's really to apply software engineering principles to enable Uber's systems to run reliably, you know, through a systems mindset and strong partnerships with developers. This is something we teach all of our PEs when they start. This is very, very important to us, and this is really, you know, talking a lot about how we actually operate. So, yeah, how do we actually do this? So for starters, and I'm really serious about this, I hate the term SRE. I was talking with Kevin earlier about this. The reason why I hate it is not that it's a bad term. I think it's very, very specific, you know, to a lot of what goes on at Google, and this doesn't necessarily apply to the industry as a whole. You know, when we talk about software engineering, if somebody says they're a software engineer, all of you know exactly what they mean. Somebody says they're an SRE or a DevOps, you know, you get a million different answers about what actually people do and what that means. But we actually feel like production engineering is a generic enough term that, you know, we'd like to see the industry move more towards like a standard definition about production engineering and what this actually means. And so what is it actually about? Like, I don't think it's any coincidence that maybe 15 years ago, you didn't really have a function like this. Why is that? We didn't have these 100,000 plus node physical data centers with all these hosts in them. We didn't have all these microservices. We didn't have service-oriented architecture. Things were a lot simpler back then. You know, we more or less had LAMP stacks and things like that we just learned to scale. But we actually created this problem of requiring, you know, an engineering mindset for production when we introduced these large-scale distributed systems, when we introduced SOA, you know, when we created all these microservices and started building all these data centers. We created all this complexity, and the only way that you can actually deal with it is through an engineering mindset. The old system administrator of old that sat down and opened up an SSH window and logged into a production host to actually fix things you just can't do that anymore, right? If you got 100,000 hosts in one data center, or even more multiples of that in containers, that is just not scalable. And so you really need to start changing the way that you think about this stuff. And so on that note, like scripting doesn't really scale, doesn't really work. You know, when you've got 100,000 nodes to deal with, like a script is going to take hours to work. Even if you try to use like GNU parallels or something like that, it's still going to take a long time to work. In addition to that, you know, you have to be a lot more thoughtful about the types of tools and the things that you build, because if you don't engineer those things in the right way, they're not going to scale either, and you'll end up just constantly battling and fighting them. And so the reality is that we need to actually build and engineer solutions, and that's why we really want to drive home the point of production engineering. That's what we're actually doing. We're building solutions that work in production, you know, help us operate. One caveat to this. I'm going to point this out specifically. This is not true for everyone. You know, I think a lot of people, for example, read the Google SRE book and they decide that this is something that they need to do. They need to do everything in the book. I actually disagree. Most of the things that I'm going to talk about today, I actually think are just a hypothesis. Like, you can consider that the things that I'm saying might be true. You can try them for yourselves. We can have a great discussion about this after the fact. I have a feeling that there'll be some good talking points afterwards. But the reality is that not everyone needs sort of this high-level engineering function. Or another way of saying this is not everybody needs to run Kubernetes. Sometimes a LAMP stack is all you need to like get the job done. So I like to think of this in terms of a ramp. And again, this is just another hypothesis to kind of think about this. So on one end, maybe you've only got tens or hundreds of hosts that you're actually running. And so like a traditional system administrator is fine, you know, like maybe you got a small startup. You haven't proved the validity of what you're trying to do or anything like that yet. So having a full stack engineer or having a system admin that logs into boxes, that, you know, has a bunch of checklists and manual processes, guess what? That's actually fine. And I'm not saying don't do that, because I think doing more large scale engineering is sort of unnecessary at that point. But at some point, your business, much like an Uber, starts to grow and it starts to expand. And sometimes that happens really, really, really fast. And so you suddenly realize that you're starting to get into that complexity that I talked about earlier, where now you've got thousands of hosts that you're actually managing. And so now this is the point where you really want to start thinking more about tooling. Maybe you're starting to write like Python or Golang scripts to automate, do a lot of the heavy lifting. Maybe you use something like Terraform, you know, to spin up your infrastructure. But the reality is that you may keep growing past this point. And again, this is just a hypothesis, but I think when you actually get into this 10,000s of nodes or hundreds of thousands of nodes territories, then the things that you were using before sort of start to really kind of break down. Something at Uber that we often say about the production engineering function is we are whatever the business needs us to be at that point in time. Sometimes it's way over here when we're starting out and we don't know if, you know, we're going to have our lunch available tomorrow. And other times it's now we're in this territory. We're managing hundreds of thousands of containers. We've got all these data centers. We've got multiple sites and regions all over the world. And so now we really need to start thinking about solving problems from a more like engineering mindset. It's not enough to just write a simple shell script. You know, we've really got to level up how we're problem solving. So how do we actually do that here? So again, I mentioned this before, but we partner with product engineering teams, AKA feature teams. We generally build actual teams, okay? So one of the things that we do not do is we do not take one or two engineers and put them on another team. We actually don't think that works that well, because what happens when you do that, those one or two engineers will get stuck with all the operations work from that team, or they'll get stuck with all the on-call work, and they will actually never get the opportunity to function as a team and actually build software. And so the minimum unit to be able to do that is a team of individuals. And so we like to think of teams of about 10 production engineers. This allows us to focus on actual engineering and production, and then it kind of gets us rid of the I don't want to do ops bias. Who knows what that is, by the way? It's you know, traditional SRE or system administration or DevOps over time and given enough scale will burn people out. And they will eventually never get to the opportunity where they're actually engineering their way out of problems. They'll just get burnt out and they'll say, you know what, I don't want to do ops anymore. And they'll quit. Or even worse, they're talking to you over the phone and interviewing at your company. And you're like, hey, this is Uber production engineering. I don't want to do ops. And literally, I've heard this a million times here trying to recruit. And so by being honest and saying, hey, we actually have teams that partner, you know, with feature teams and, you know, help improve reliability, and that's our minimum unit of problem solving, then that starts to get people to realize that, hey, this is a different way of thinking about this. The last thing is, once you have this team of PEs, it allows you to do something, and it's this term that we've coined here at Uber called process automation driven development. All this basically means is once you have a team that can work on solving problems in production, and once you solve all the basic level of problems like spinning up infrastructure and things like that, then that team is now able to look at processes or things that other product or feature teams are doing in production and figure out ways of automating those things. This is just another way of saying that you can start focusing on solving like all the complex orchestration problems. Like at the infrastructure layer, that may be figuring out how to pivot a MySQL master, if one fails. But as your company grows and as it expands over time, like the actual operational problems that you have start getting more and more sophisticated. Can talk about some of these specific places with Uber sort of afterwards, because there's actually some really interesting operational problems Uber focuses on, and that's specifically because I think of us as an operations and logistics company. We run in all these markets all across the world, and there's all this sophisticated stuff always happening behind the machines, and production just needs to be able to deal with that. So, process automation driven development. I'm going to use a very simple way of explaining this. How many of you have ever had to add users to a company before? Okay, so that's a few of you. This is like one of the most basic things that, if you're starting at a startup and you're helping them spin up their infrastructure at scratch, that you tend to do. And so what happens? There's always one engineer that knows how to do this in the beginning. And that engineer basically comes up with a checklist or process for adding a new user to production. And it's funny that you were talking about this, Kevin, because this is exactly illustrating my point. So you have that one engineer that knows how to do this process. And then generally, that engineer, hopefully is smart, they will eventually say, hey, I'm not going to keep doing this by hand. There's all these problems that I always run into. Sometimes I make mistakes or missteps. So that engineer will take that process and turn it into a script. It's like, great, now you have this script for doing this. But maybe that script only adds users, and suddenly your company gets big enough that you have to start deleting users, or you have to start changing users' information. So that engineer then takes that script and turns it into a more general purpose tool. So instead of the LDAP add user tool, it's now the manage user tool. And which is great, but in general, this tool maybe only works on one engineer's laptop, right? And anytime you want to add, more than one user at a time, or you have two or more people that want to work on this, now this tool starts stepping over each other and it causes all these problems. So now you've got the bright idea, okay, well, you know what? I actually just need to turn this into a service. This service should actually run in the cloud. I'll give it a REST API. I'll create a CLI for it that it uses. And now I've got a much more, better service for actually dealing with this. But then lo and behold, you get to Uber scale and you're now adding, hundreds of users every day, or thousands in some instances. And this simple service is not enough. You need a full-fledged system with replication and a database and a caching layer. And so now you're getting to this total user management system that spans the globe and has multiple engineers working on it. And so this is unfortunately the normal workflow that things tend to happen with when you're going from small startup mode, to sort of big company. And one of the things that we always like to get people to think about is, let's stop by skipping the first 3 steps. When you start solving a problem, start with the service or move on to the system. At a very minimum, take that process that you have and don't just write the process. Start with a general purpose tool at least. But generally, we like to think of problem solving in terms of services and systems. And this is like when we really start to get into the differences of what is an actual engineer versus, an administrator or someone that's just going to sit at the keyboard and problem solve, one problem at a time. So last way of kind of looking at this slightly differently, people tend to create processes. Processes should evolve into products or systems, and very, and I'm a big fan of lean startup, but very similar to like the lean startup methodology. You don't just solve the problem once. You kind of go through this iteration cycle where now you've got this service or the system running in production. You can quickly iterate, you can add more functionality, but you treat it just like any other engineering problem that you would ever deal with. This is how a lot of product teams operate when they develop and ship software. There's no reason why production engineers shouldn't be operating and thinking the same way. All right. And so this is actually a little bit more specific to Uber. I'm going to kind of gloss over this a little bit. But this is just one way that we think about the different layers of problems that we actually solve over time. And again, once we have a lot of the basic infrastructure, not basic, but the infrastructure level problem solves, things like, you know, networks and databases and compute, et cetera, what happens after that? And we generally start looking at problems on the on-call, instrumentation, incident management level. Then we kind of move up into, you know, more automated capacity, forecasting and testing, you know, failovers, load testing, you know, turnups, like spinning up, you know, resources in completely new areas, completely automated. If you remember our mission, anytime Uber decides to go into a new city and start operating, we should just edit a config file, add city, click deploy, and it should just work. And that should be, you know, that should be capable anywhere on the globe. You know, that's sort of the second layer. The third layer, it's just around tech and process convergence, you know, being truly like globally distributed and all that good stuff. And then this sort of top and last layer is where we really start getting into the deep internals of the system. Uber today has about 4,000 microservices, 4,000. Yes, I didn't make that number up. And, you know, we have numerous products and numerous verticals. So at some point, when we get closer to that 10% ratio, we want to actually be able, you know, we want to be across all teams and all verticals and really able to jump in and influence how everyone at the company thinks about reliability. All right, so now we're going to get into the meat of this presentation. So now that we've kind of identified what we're looking for, how do we actually find and hire these people? So this is another Sumbry quote. If you know me for any time, I've got about 1,071 of these quotes. They just pop up randomly. And this is one of the big ones. I don't think you really find production engineers in the wild. I think you have to create them. And I'm going to get into that in a little bit of detail. But I think the reality is this discipline is new enough. Not enough people have done it at the scale that we're talking about. And you're really talking about the Googles, the Netflix, the Apples, the Facebooks, et cetera, of the world that have sort of operated at this scale and are dealing with this level of complexity. So the reality is, you've got to actually go out and find people that are interested in doing this, that sort of have a lot of the right, like initial early warning indicators, for lack of a better term. And then you've got to train them and grow them to really fill out this role. And so when we think about hiring, there's a couple of things that we really look for. And so, you know, the simplest way of saying this is I can look for a normal software engineer and I can evaluate somebody and give them a coding exercise and say, okay, you know what? I'm going to rate your ability to be a software engineer at this level on a scale of 1 to 5. Now, the reality is that that's not enough for us because we actually are looking for someone with a systems understanding as well. I'm going to further define systems in a little bit. But if we're looking for someone with the systems understanding, and if this is on a scale from 1 to 5, and this is on a scale from 1 to 5, then I am actually interviewing people and looking for people that fit in the gray zone. And the gray zone might be somebody that's a 5 on software engineering, maybe a 2 on systems. You know what? That's good enough. I can train them, bring them in, and eventually get them to a 5-5 on both. And that's like a lot of the strategy that we look at. So even when we hire and we interview people, you know, if we're ever in a tough mode where we have to make a decision, we'll literally say, okay, let's evaluate their software engineering knowledge and let's evaluate their systems engineering. Where do they fit on the green zone? And again, the green zone, you could be great on systems and not be the best software engineer, but guess what? We'll give you the space to learn and grow and level up that software engineering skill, or vice versa. And so this just kind of reflects the reality of what we see in the wild, where somebody is usually great in one or the other. In a very few scenarios, do we actually find the 5-5s? Probably 5% or less. The reality is you're great in one or the other, and you know we'll just sort of design everything else to kind of level up, you know, what may be lacking. So on that note, as far as our hiring strategy is concerned, we actually bucket people into 3 groups. So the exact match, 5% of people. I think that for every 100 people that we hire, 5 of them will actually be exactly what we're looking for in this role. The other 2 groups are what we just kind of call pivoters and growers. And I'll jump into what that actually means in a second. Grower, this tends to be someone that's earlier in their career. They've got less tenure, you know, maybe they're an inch to a senior engineer, something along those lines. They're generally strong on software engineering. Maybe they, you know, leveled up their software engineering skills in school. but they're generally weak on systems. The way you get good with systems, unfortunately, is not at school. It's by like just being out there in the wild and dealing with this stuff. And so generally anyone that's in the grower category, again, they're a little bit earlier in their careers, strong on software engineering, weaker on systems. The opposite of that is the pivoter. This is someone that is actually tends to be later in their careers. So they've got all this really good systems experience, but no distributed systems experience, no production engineering experience. And so in some cases, we can take that person that's really, really interested in leveling up the distributed systems and say, okay, well, you're a great software engineer, you've got all this experience in your career, we're gonna basically take that and pivot you and sort of teach you all this other stuff that you haven't been exposed to. And much like the grower, it's just about teaching and giving the opportunity. So in addition to that, a lot of this I've said, a lot of what I've said is all about the opportunity and recognizing that we have to grow people in this role. So now onboarding becomes especially important. So one of the first rules we have, 6-month rule. It takes anyone in this role at least 6 months to onboard, and we're just being realistic. You have to learn all the infrastructure of the company. You have to learn all the, you're working with a product or a feature team. So you've got to learn about all their services, and then you've got to be able to function in the middle, serving as a translator and an advocate. And you know what? This takes at least half a year to do and to do well. And so a lot of our processes are designed to recognize that fact. I'm not going to give you a negative performance review after 3 months because I just said it's going to take you 6 months to onboard. And we're very realistic about that. And so this reflects in onboarding and coaching and mentoring and performance reviews. In addition to that, we want to also give you the space to learn and grow. If you're a grower or a pivoter, we want to give you that space, but we also want to use the 50-50 rule. Like half of the time, you will be able to actually learn and level up this stuff in the office. The other half of the time, we actually want you to do that, on your own as well, too. This is not all about, us just giving you 100% of the space, but it's got to be a little bit of a balancing act. So we expect you, you can take half the day at the office, like learning Golang. We have a lot of engineers at Uber that join not knowing Go, and we've given them the space to learn it here. But, you've got to take a little bit of personal responsibility and, try to push this stuff on your own as well. And then in addition to that, we want to make sure we have strong coaching and mentoring systems. Again, if it takes 6 months to learn and navigate the ecosystem, then it really helps if you've got a guide, if you've got someone helping you lead the way. And one of the things that we do is we also hold both the mentor or coach and the person getting mentored or coached equally accountable. If the mentor fails, you know what? During performance review time, I'm going to call that out. I'm like, hey, what happened to this person that you're supposed to be teaching and helping to level up? Like they completely failed. Like this is half your responsibility. And so we're actually very honest about that. All right, and so the last section I'm going to talk about is, so now that we've talked about, we've talked about like the specific function, how to hire, how do we actually evaluate people like this long-term in this sort of production engineering role? I have not used the word SRE once, well, I just did right now, but unintentionally once during this entire presentation. And so very quickly, I'm going to describe this in the way that Uber describes our own internal competencies going forward. And so competencies, it's just the knowledge, skills, and abilities required to perform your job function in a specific area. And so that's it. Uber's got a specific set of competencies we evaluate engineers on. I'm sure all of your companies do as well. And so I'm going to present what we use, but feel free to take from this what you'd like. And so before I jump into the competencies, so a quick notion on what we call our production engineering or PE principles. One of the interesting things is that years ago, when we really started thinking about what it meant to be like a production engineer and really do this function, we actually came up with a list of 10 principles. And I'm not going to cover the 10 principles here, but one of our principles was sort of this acknowledgement that this work requires being good at both software engineering and systems engineering. And I called that out in terms of how we hired. But one of the things we realized after a couple of years is that we didn't actually describe anywhere what systems engineering was. And I've just gone through this entire talk. I've referenced it several times, and no one here has actually called me out on what is systems engineering. And I think it's probably because of two reasons. One, it's a very broad topic, so there's maybe not a singular definition of it. And two, I'm just going to use this opportunity to actually describe what that means here. The PE principle stated that production engineering requires both software and systems, but we didn't actually describe what systems is. So how do we actually define this at Uber? And at Uber, we define it as three things. Systems engineering is your knowledge of Unix systems, your knowledge of distributed systems, and your knowledge of what we're calling reliability engineering. Now, this is just one useful way of describing how all of this works in terms of the software development lifecycle, but it's just this notion that, you know, all of this stuff happens over the lifecycle of taking some code and getting it to actually work well in production. We're actually saying, you know, systems engineering is being good at sort of all three of these things. Now, again, this is just a hypothesis. I don't know if this makes sense. You know, feel free to debate and argue this with me afterwards, but I'll jump into specifically what these three areas are. So Unix systems, your understanding of Unix and Linux. And this is everything from the kernel, the operating system, memory management, file systems, performance tools, networking, you know, configuration management tools, you know, lots of open source software. These are generally things that work on a single host and kind of understanding the things there. Distributed systems are now things that span multiple hosts or distributed systems technologies. And so this is just things that span multiple computers over the network. So technologies like Mesos, Docker, and Kubernetes, service discovery systems, service mesh systems. By the way, when I first started using service mesh systems, we didn't actually call them that. And so I think it's weird that there's now a term for this thing that I've been doing for years at another company. In addition, it's just like network distributed systems, networking technologies, you know, distributed storage technologies, HDFS, you know, NFS. You could kind of classify NFS as that. And then also you got these distributed logging systems, databases, and then actually the public cloud components itself. So this is the second component that we consider systems engineering. And then the third is this notion of reliability engineering. And so this is a lot of the stuff that like we've kind of been talking about a little bit earlier today. Things like how do you engineer these reliable systems at scale? Things like PRRs, end-to-end testing, incident response, incident mitigation, fall injection, things like Chaos Monkey, things like that, smoke testing systems that run external to your environment and validate functionality. All the chaos engineering stuff kind of fits into this category. You know, postmortems, root cause analysis. I'm a big fan of the 5 whys and things like the OODA loops. Like these all fit into sort of this category. In addition to that, any work around efficiency, you know, performance, scalability. We think this all kind of nicely fits into this third, like, reliability engineering category. That said, in summary, we have a production engineering role, which consists of all the engineering competencies in addition to the systems engineering competency. Systems engineering is Unix systems, distributed systems, and reliability engineering. And PEs are usually created, not born or easily found in the wild. Your processes should basically be designed to help build those people up.